my TTL computer running at revision 2A, I'll call it. First time it's running the up-down program in 2-byte mode, 2-byte instruction word mode. Also addressing 256 bytes of memory. So we're basically got everything completed, and I think running pretty stable now on revision 2A. A lot of changes made. Again, in the last video, I declared victory on 2-byte instructions, and that wasn't really true. Still had hardware issues to resolve that were sporadic, but surfaced. Even if you look at that video, it was running the up-down program, you could see the sequence skip a few times, and I saw that when I watched the video, but I didn't see that when I was running it, looking at it live, and declared victory. But lo and behold, no, many issues resolved since then. I had so many issues to go through that I probably wouldn't enumerate them all, but again, I was almost gave up multiple times in trying to get to this revision 2 of the hardware. A lot of issues with the the control lines, the pull up and the pull down resistors. Again, I changed the display up here, the bus display, to have a driver chip, so it doesn't it's not a load on the bus. I changed all the the display resistor values on the memory address register display and the opcode display to cut down the load on the control lines. I completely re-implemented the control logic here for when the registers were loaded, when the memory address register was loaded, when the instruction register was loaded, and also when the A register was loaded. I had to add in an extra logic chip up here to redo the load logic for those registers, which was kind of piggybacking off of the logic for the RAM chip write signal, and that just was not working because there's a small little negative signal behavior that was happening there, and a little bit of a delay, a 10 microsecond delay because of the piggybacking the RAM chip write, and that is, I think, was the source of a lot of the glitches that we saw in the up-down program, beside just the control level signals being bothered by the LED displays that that controlled the control logic that was being used to piggyback off of the RAM chip write was causing the issues. So I had to, I said, add in an extra chip and redo that logic, and so it's got its own logic that is being driven separate from the RAM write signal logic, and I think that's really going to clear up the glitches. So I'm pretty confident now that, although I've said that before, but I'm really pretty confident at this point that that was the source of a lot of the flakiness that we saw, where things were just going into AFib, I'll say, where things were just not working right at all, and apparently losing synchronization. But I think that was it. And I think that because of that change, we're running here at the highest clock speed that I have implemented on the clock right now, which is at 250 hertz. And it's running pretty well. And I'm confident that we could bump up that clock speed further now, which I probably will do at some recent juncture. I'll bump that up to 500 and maybe even up to 1,000, a 1K hertz signal, which is going to be pretty good. One thing I did notice after all that stuff was implemented, that getting some weird behavior on my input switches after I did all of that, and I had no idea what was going on there. But then finally said, "This is again a power problem," and I threw the voltmeter down here on the switch driver chip, and I noticed that as I went, enabled each of these switches, on in sequence individually, they work fine. When I started, adding them so that they were all on, the voltage on this chip was really starting to drop and get bad results when you looked at the display LEDs. So I increased the resistance on these driver resistors for the LEDs to kind of cut that down. I still see a little bit of wonkiness, and you can see the green LEDs are much brighter than the yellows. The yellows are not apparently as efficient, but I might increase the resistance on those green LEDs just to cut down, hopefully try to, again, cut down the power draw on this chip. I'm not exactly sure why that's really occurring, but yeah, that this driver chip can draw so much current that it's pulling down the voltage. But anyway, yeah, that's a lot said, but I think we're good. So this is basically, I'll call it Rev 2A. Everything is implemented, but to start adding the serial I/O chips. But before I do that, I want to make sure all the instructions are working at 2 byte, and I also want to implement the call and return instructions, and that's going to be implementing the stack. And I also changed the bus, so it had pull down. Was using pull down resistors there. I changed that to pull ups, so which is going to be needed when I implement the stack pointer, because when I release the bus, that basically is going to put an FF on the bus because of the pull-ups, and that's going to be the address of the stack pointer. Stack pointer will be the last bit of memory in the RAM, but this way when we release the bus, that will give us basically the address of the stack pointer, which is what the microcode is going to need. So that'll be the next thing I do. But hey, things are looking pretty good. It was a heck of a lot of work to get here, a lot of hair pulling, a lot of frustration. So I almost gave up, 3 and 4 times because things were behaving so badly. But I think it's looking pretty good now. Anyway, thanks for watching.